Hello once more. Today we're going to do 4.8 modeling real world data with polynomial functions, which means you need your calculator. So please grab it if you don't have it. All right. So first thing to talk about is polynomial functions, what they look like. Okay. First one is linear. It is in the form of y equals ax plus b. It is a line of some sort, or a grouping to look more like a line. It changes direction 0 times. The next one is a quadratic, ax squared plus bx plus c. It is a parabola shaped. It changes direction 1 time, so we're going up, we change to go down. Next one is cubic, ax cubed plus bx squared plus cx plus d. And it changes directions 2 times, so we're going up, change down, change up. Okay. Last one is quartic, which is to the 4th power. Ax to the 4th plus bx cubed plus cx squared plus dx plus e. 3 changes of directions. You'll see in the directions for how to do these that you'll need to take a look at these. But what's going to happen is we are going to plot data, and you're going to use that data to decide which one of these equations you should use based off of its picture. Okay. All right. So let's go through step by step how to find these. So first one, the problem says write an equation to model round to the nearest 1,000. So here is our data that we are going to put in. Okay. All right. So number 1. Input the data into, let's see if I can get my calculator on here too. I'm going to move my light around so you can maybe see my calculator better. Okay, let's try it out, and if you can't, I'll see if you can see it. So we're going to push stat. Can't see it. Okay, hold on. That's not going to work. Okay, you can see that. Okay, so you're going to push stat, then you're going to push edit, and we're going to input this data in. What we're going to do instead of, well, first of all, this is going to be your L1. So this is going to be your first list, your X's. This is going to be your L2. Okay. And instead of putting all these years in, we are going to make them be numbers. So this one's going to be 0. This is 5 years after 0, so that's 5, 10, that's just 1 year, 11, 1 more year, 13, 14, 15, 16, and then this one will end up being 21. Okay, so we're going to plug them in that way. So I'm going to plug in 0, 5, 10, 11, 12, 13, 14, 15, 16, 21. I'm going to go back over to L2. We're going to put all those in. This is always like the hardest part. We somehow always make mistakes in putting data. 4.5, 4.4, 4.5, 4.5, 4.5. I'm going to check. 15 should be 4.4. 4.3, 4.4, all of them match up. Awesome. Make sure they coordinate and match to each other. Okay. All right, number 2, you're going to push second stat plot. You're going to make sure your plot is on. Mine is off. On. Okay. All right, that's it. Adjust your window. Make sure it's on L1 and L2 because that's where we put our data. Okay, we're gonna go to window. We're gonna adjust our window to our function. Our x went from 0 to 21, so maybe I'll go from -1 to 22 by 1 so I can see it all. And my y's went from, I could probably go from 0 to 5 because it goes from 3.7 to 4.4, and I'm going to push graph. I have something in my y equals, so I'm going to clear that out and push graph again. And we're going to take a look at what does this look like. It kind of looks like we go up and maybe back down. This one's not great. Okay, so maybe I zoom in my window a little bit more to 2. Okay, see more of a parabola shaped there. If you're having a hard time seeing your shape, change your window again. So I'm going to go with a squared. Okay. All right, so that's this. What does it look like for us? I'm gonna pick a squared for this one. The next we're gonna go stat. So we're gonna click stat. We're gonna go to calc, and we're gonna pick the regression we picked. So we picked quadratic here. So I'm gonna go down to quadratic regression, but you'll notice there's linear, quadratic, cubic, quartic. Okay, I'm gonna pick quadratic and push enter. And it is going to give me all of these numbers to plug in. Okay, so I'm going to write them out to 3 decimals. So I have y equals, a goes to the squared, so -0.003x squared plus 0.108x plus, last one would be that needs to be rounded, so 61. Okay. All right, there's my equation. So the next question says, use the model to predict the amount of waste produced per day in 2010. So the first thing we need to do is figure out how many years 2010 was. Okay, well, we started with 0 at 80. So 2010 will be 30 years after that. So 2010 is going to equal 30 years. So we're just going to plug that in to our equation for x. So legitimately plug that into your calculator. When you do, we're going to get that y equals 4.15. Does that number make sense with our data? Yeah, I mean, it's right in the middle of our data. Perfect. Last one, use the model to predict when the amount of waste will drop to 3 pounds per day. So we want to know when y equals 3 pounds. So we're going to plug that in. So we'll say 3 equals, I don't need that, x squared plus 0.108x plus 3.61. Okay. We want that to be 0, so we can use the quadratic equation. Plus 0.61. Okay. And now we're going to plug that into the quadratic equation to see if we can find out when that will occur with x. So we will have -b plus or minus the square root of b squared, 0.8 squared, minus 4 times a times c all over 2 times a. Okay. All right, remember that this is a plus or a minus, so you'll put that in your calculator with a plus, then you'll put it in your calculator with a minus, and we'll come out that x equals -5 and 41. Okay, So we got to figure out what those are in years, because we want to know what years that'll happen. So -5 will be 5 from 80. So we'll go back 5 to 1975. And then 41, we need to keep going. So 2010, we're at 30. So 11 years after that would be 2021. Okay. So there is our answers. Okay. I will give you extra credit on this assignment if you can go on and see what the amount of waste per day in 2019, and see if they have an estimate for 2020. Add that amount into your classroom comment when you submit your answer to me for this assignment. Okay, interesting to see if how the model is and if it's been accurate. All right, so your homework is page 262, 1 through 10, 17, 23, and then 25 to 27.